Hi everyone, this is Statistics. We're looking at Unit 9, specifically 9.1, and we're going to be estimating parameters using confidence intervals. I'm just going to read a little bit of this and then I'm going to go straight into some examples. I do have a note at the top here, and the note is the goal of inferential statistics is to take information about a sample and use it to draw conclusions about a population. We've seen this before. This isn't anything new to you, but we're just going to kind of extrapolate on previous ideas. So we apply the results about the sample mean to the problem of estimation, where estimation is the process of using sample data to estimate the value of a population parameter. We will quantify the accuracy of our estimation process. So again, Unit 9.1 is going to be estimating a population proportion. Sometimes your population proportion is going to be given, but a point estimate is the value of a statistic that estimates the value of a parameter. So here we have an example 1. It says if we are doing a poll and 68% of the respondents marked yes to the question of concern, then we would estimate that 68% of the population proportion would also say yes to our question. We call this p hat is equal to 0.68. The point estimate of the population proportion, or hence, again, p hat. Now we want to recall that the point estimate of the population proportion is given as p hat equals x over n. And that's important to know this equation here, because sometimes you'll be given p hat and then sometimes you'll actually have to calculate it yourself. So it's just dependent on what the problem gives you. Now, understanding confidence interval, the definition of confidence interval for an unknown parameter consists of intervals of numbers. The definition of confidence interval represents the expected proportion of intervals that will contain the parameter if a large number of different samples is obtained. And so we have a confidence interval right here. Confidence interval estimates for the population proportion are of the form point estimate plus or minus margin of error. Usually a confidence interval will be given to you, and so we have some down here. As the level of confidence increases, the margin of error increases. This level is most commonly at 90%, 95, or 99 confidence level. In problems, we'll tend to give that to you, but you'll see that in a moment. Sample size, you've seen before. As the size of the random sample increases, the margin of error decreases, meaning the more people that you're sampling, you're getting closer and closer to the size of the population. So because your sample size is increasing, and that reflection of that increase will be of a reflection of the population as a whole, then your errors should decrease because, again, you're sampling more people. Now, the less people you sample, the likely your error is going to be bigger because, again, it's not as reflective as it could be of the population, whereas if you sampled more people. Number 3 here says standard deviation of the population. The more spread there is in the population, the wider the interval will be for a given confidence level. You've seen standard deviations before. Again, that's talking about spread of data, very similar to variance, except we don't like to always utilize variance because it's kind of what's the term I'm looking for? It's kind of a difficult concept to not just grasp visually but also conceptually. Whereas standard deviation, it's a lot easier to utilize the empirical rule, at least one method, to understand standard deviation. So a lot of times it's just easier to utilize that to show the spread of data against the mean. So let's move on here. You're going to need to know all this information here. ME's margin of error. You're going to need to know that. You'll have all these formulas on your exams as well as your notes to supplement the help in the problems that we're going to go over, not just in this video, but also class. And then here is a critical table. You can kind of think about this almost like a z-score table, sort of, where we have frequency used confidence levels and their critical values are and they're given. So you're going to utilize this table when you have confidence intervals that are listed because you're going to need this z alpha over 2, and we give those values here. So again, you're going to need this for your calculations. I just wanted to make it apparent on where you can find it in your notes. Okay, we have our first one here. I have it pre-filled out. I think it'll make the video shorter, but let's read this. It says a poll of 500 voters were asked if they were in favor of Kanye West becoming the next president, and only 235 pollers were in favor. Obtain a 95% confidence interval for the population proportion favoring of Kanye West being the next president. Interpret the results. Okay, just like we saw in chapter 8, we're going to write down our givens here. Our sample size is 500. our n is equal 500. Well, we need to calculate our p hat. If you notice, we actually don't have our proportion given. So we need to take our x value, 235, over our n, and we found our population proportion is 0.47 or 47%. So we want to do that calculation. Again, I know I keep repeating myself, but sometimes that p hat will be given. We have our confidence level here. That is, or well, confidence level, but also interval, is 0.95. 0.95. Well, we need to look this z alpha over 2. We need to look that up at 0.95. So let's look that up. I know I have the answer here, but I want to walk you through it. So we need to go to our table up, 0.95. The table I was just showing you, 0.95. And we should have a z alpha over 2 of 1.96. 95, 1.96. So that's how you're going to find it. So now that you have all this given information, you have it presented for you, it wants us to write our parameter. And this is going to be a sentence. So parameter is labeled as P, and what that's going to equal is your population proportion of voters who favor Kanye West to become president. Now, how did I find that? I just read the paragraph, and then I obtained what the parameter was talking about. Again, population proportion of voters who favor Kanye West to become president. That information was obtained within my information here. Okay, just like 8.1 and 8.2, we have conditions that need to be met here. This formula right here is in your notes. It's up in the page above. But we have p hat times 1 minus p hat times n is greater than or equal to 10. Well, we know what p hat is. We calculated that. That's up here at the top. That was 0.47. I did 1 minus 0.47, gave me 0.53. The n value was given up top in the problem as well. So when we do that calculation, we get 125 is greater than or equal to 10. So it more than meets the conditions that need to be met here, so we could check that off and move on. This is where the calculations come into effect here. Now, this formula right here, again, is given in your notes already. Of course, it will be supplied on your exam. But what we have is our p hat plus or minus, and then this is our margin of error, all this information here. So if you recall, this is our point estimate. I would add this in your notes. I think it is helpful. And then the whole calculation on the right-hand side, this plus or minus calculation, is our margin of error. And again, the bigger your sample, the smaller your margin of error you would expect to see. The smaller your sample, the greater the margin of error you'd expect to see. Now, we know what our p hat is. That was 0.47. Again, that was information we had to calculate from the given paragraph. Plus or minus, this z alpha over 2 was based, if you recall, on our confidence level or our confidence interval of 95%. And we went up to that table up here and we said, okay, confidence level or level of confidence is 95%. My critical value is 1.96. And that's what we have right here. And that gets drawn right here. Now, all this stuff inside is easy. Our p hat, again, was 0.47. 1 minus p hat was 0.53. All over our n, that was given inside the problem, and we want to take the square root of that. What I would do first, guys, I wouldn't try to enter all this in your calculator. I've seen a lot of you guys do that, and there's a tendency to make a mistake. So I would calculate my numerator first, divide by the denominator, and then figure out the square root of that, and kind of break things up into chunks as you'll decrease the amount of errors that you make, or the possibility that your calculator might make by you putting an error into the calculator, or order of operations kind of going random on it. So if you did the right-hand side, your margin of error was 0.044. So you'll have 0.47 plus or minus 0.044. Well, what is our confidence interval then? You need to do 0.47 plus 0.44, and then 0.7 minus 0.044, and you'll get your confidence interval. Well, what does this mean? How can we interpret this? We can say here, and the language here is very specific, guys. So I want you to write this very specific. You're going to see this is very similar to you interpreting things in prior chapters. And remember how I gave you that syntax diagram where Wherever the X value was, you'll put something there. Wherever the Y value was, you'll put something there. It was kind of underlined, fill in the blanks. Do something very similar here. We are 95% confident that the population proportion of voters who favor Kanye West to be president is between 43%, I rounded up, and 51%. Okay? So this isn't really going to change that much as far as what your interpretation is or your conclusion of the data that's being given. Now, I do want to zoom in here on the confidence interval. These are just a range. So I have a note here. This gives you the range of what your population proportion should be. It should be between 43 and 53% are going to be in favor of Kanye West. And we're about 95% confident in regards to that data that's being presented or the data that we're calculating here within this problem. So I don't think these are too tough. It's just plug and play pretty much and then solving. Let's go on to our next one. It says, in the parent teen cell phone survey conducted by Princeton Survey Research Associates International, 800 randomly sampled 16 to 17-year-olds living in the United States were asked whether they have ever used their cell phone to text while driving, which obviously we should not do. Of the 800 teenagers surveyed, 272 indicated that they text while driving, obtain a 99% confidence interval for the proportion of 16 to 17-year-olds who text while driving. So just like we saw in our previous unit, Chapter 8, or Unit 8, we're going to write down our givens. I didn't highlight everything here, but there's 800 teenagers that are surveyed. 272 were indicated that they text while driving. So we know that the number sampled, and that, if you want to be a little bit more clear, it actually tells you sampled right here. N is 800. Our p hat is not given, so we have to calculate that. Remember, that's x divided by n. That gives us our proportion of 0.34. And then we have our confidence interval level, or confidence level is 0.99. That was given as well. And then we need our z alpha over 2. That's for our calculation down below. So I suppose you could find it later. It's just helpful to get it out of the way now. So we need 0.99. We go up to our table way up here. 0.99, 2.58. So 2.58. And we write that down right there. Again, it's just helpful to get it out of the way and do it now. That way you have everything presented in front of you. You just plug and play and you move on. Okay, so what's our parameter here? P equals population proportion of 16 to 17-year-olds who test while driving. Again, the parameter is information that will be found within the paragraph that is given. You got to really know what the question's asking, or else you're going to be kind of confused on how to figure out what your parameter is. So if you get the gist of what you're looking for here, this is not too shabby, not too hard. Okay, our conditions here. I copied and pasted the formula for this one. We have n times p hat, 1 minus p hat is greater than or equal to 10. Our sample size was 800. Our proportion was 0.34. I did 1 minus 0.34 to get 0.66. It's greater than or equal to 10. And if you do that calculation on the left-hand side, you get 174. 174 is drastically greater than 10, so we are good to go. Our conditions are met. I know I'm going fast here, folks, but a lot of this you're more than capable of doing. You're capable of plugging things into a formula now and solving it. And then we have our calculation. I copied and pasted the formula. I think it's a little bit more cleaner than what I had before. If you remember and recall from the previous example, p hat, you should be thinking point estimate. Again, p hat, point estimate, plus or minus z alpha over 2. If you recall, that is right here. Let's go back up. That is our critical value that was based off our level of confidence that was given within the paragraph. And then what we have here is under our radical, we will have 0.34 times 0.66 divided by n, which was 800. Like I said previously, break this up into chunks. Don't try to do this all at once. Could you? Sure. It's better to be safe than sorry. As always, make sure you run the calculation a couple times. Make sure you're getting to the correct intervals, the correct ranges here. It's better to be safe than sorry, especially on exams. So this right-hand side is your margin of error. Again, point estimate, whole right-hand side, margin of error. So we have a margin error of 0.043 or 4.3%. So 0.34 plus 0.043, and then we have also 0.34 minus 0.043. We get basically our range, if you want to look at it that way from maybe like algebra. But it's going to be basically 30% to 38%. And then we want to interpret or write our conclusion of this. And if you notice, this interpretation is actually very similar to what we saw before in our previous example. We are 99% confident that the true proportion of 16 to 17-year-olds who text while driving is between 30 and 38%. I would say this one, if you want to star this conclusion, I think the language is a lot more clear. I use the idea of true proportion. I think it's a little bit more accurate in verbiage or language. Again, it says we are 99% confident that the true proportion of 16 to 17-year-olds who text while driving is between 30 and 38%. And then moving on here, determine the sample size necessary for estimating a population proportion within a specific margin. This is just something you have to calculate. I'm not sure if we're going to have you calculate this or not, but with that being said, it's just a simple plug and play for the most part in finding the sample size needed for estimating P. Just as if you plugged everything into the formulas before, based on the values that are given down here, you would plug it in. This might be something that I go over in class. Again, it is optional here, but if we do have to do it, I will go ahead and update you and teach you how to do that. So that is the conclusion of 9.1. I was trying my best to keep this video short. Again, as we've talked about in class, make sure you're reading this on your own. Try to understand the gist of what is happening. You've had an idea of what is going on from prior units for this unit. But with that being said, thank you everyone for watching this lecture video, and I'll see you soon. Take care.